Okay, so here we are, day 2 with implicit differentiation. And just to refresh your memories from yesterday, we're going to take the derivative of everything, but now that we have a y value, we know that dx equals 1. And we don't normally write it in because we know it equals 1, but we don't know what dx equals, so we have to add it in when we're differentiating. So, example 1, find an equation of the line tangent to the circle at the point 3, 4. What we're going to need to do first is take the derivative with respect to x on both sides. So, I'm going to write d dx of x squared plus y squared and d dx of 25. Then, what I'm going to do is apply the same rules as I did before, but when I'm differentiating with y's, I have to write dy dx after. So the derivative of x squared is just 2x. The derivative of y squared is 2y dy dx. And the derivative with respect to x of a constant is just 0. Since we are going to find the derivative, we are trying to find dy dx. So now I'm going to solve for dy dx. I'm going to isolate it. So I subtract 2x off both sides of the equation, leaving me with 2y dy dx equals a negative 2x. And then I am going to solve, like I normally would, for dy dx. I'm going to divide both sides by 2y. So here, those 2y's will cancel. Over here, negative 2 divided by a positive 2 is a negative 1. So we'll be left with negative x over y on the right side equals dy dx. And what this is this is dy dx. So this is going to still give us the slope for a tangent line. It's now that we have an x and a y, and so far, before 3, 7, we would just have an x value to give us the slope. So the slope at the point 3, 4, in order to find that, I have to plug x and y into my dy dx. So I do that. Dy dx at the point negative 3, 4 would, or at 3, 4, excuse me, would be negative 3/4. And that's going to give us, just like it did before, the slope of the tangent line. So now that I know I have the point 3, 4 and a slope of negative 3/4, that leaves me with the tangent line having the equation y minus 4 equals negative 3/4 x minus 3. Then we are also asked for the normal line. Here's the tangent line. The normal line would still go through that same point, but its slope is going to be perpendicular, so opposite reciprocal of negative 3/4. So the normal line, or orthogonal line, would have equation y minus 4 equals 4/3 x minus 3. If I wanted to know what this would look like, implicit differentiation is used on implicitly defined functions, which means if I graph this together, it actually won't be a function. Well, you could make it into two functions, two semicircles. This is a circle with radius 5, centered at 0, 0. So if I wanted to sketch a picture of what this would look like, I would make my circle. You guys all know what a great drawer I am. Oh boy, it was pretty good until I got to that last part. So the 0.34 is on the circle. I mean, 3 squared plus 4 squared does give you 25. So it is on the circle. So we're going to fudge this and make sure we get it on the circle. It should be on the circle. Okay. There it is. There's the 0.34. And so if you drew a tangent to that, hopefully it looks like that it has a slope of negative 3/4. But that would be this line. That's its equation. And this one, the normal line, would look like it was just coming right in perpendicular to that circle. And so that would be a visible representation of what the relation and tangent and normal line would look like.